The James Webb Space Telescope, JWST, has just unveiled something truly both mesmerizing and profoundly disquieting about the universe's earliest epochs. Scientists are now asserting, with a mix of wonder and unease, that the galaxies they've discovered, emerging from the veil of the cosmic dark ages, appear to be almost perfect mirror images of our own, incredibly mature and surprisingly abundant within the first mere billion years after the universe's explosive birth, the Big Bang. This unprecedented observation directly assails and utterly challenges the very bedrock of our prevailing cosmological theories, which steadfastly insist that the universe meticulously unfolded and evolved in a slow, gradual, and meticulously orderly fashion. Yet, as these intrepid scientists peer ever deeper and with sharper eyes into the nascent universe's luminous infancy, they continue to unearth even more astonishing and, frankly, disturbing findings. The sheer volume of galaxies being observed is exponentially greater than any prediction our models dared to conjure, and there seems to be no discernible end in sight to this cosmic cornucopia, creating an almost existential sense that the universe itself has no clear, definitive beginning or end, but rather an endless, repeating tapestry. Indeed, some scientists are now grappling with the mind-bending notion that it appears as if we are witnessing the exact same universe again, a startlingly precise mirror image of our present-day cosmos, appearing miraculously near the very moment of the Big Bang. This profound observation is not merely interesting. It is deeply unsettling and ignites serious, fundamental questions about whether there exists any truly predictable, underlying pattern in the grand, majestic evolution of our cosmos at all. If the universe's evolution isn't a predictable progression, what does that imply for our understanding of its fundamental laws? Lou Shamir, an astute associate professor at Kansas State University, has articulated some genuinely worrying insights regarding these groundbreaking discoveries spearheaded by the James Webb Space Telescope. He specifically highlighted that while the James Webb Telescope provided unparalleled, deep-field images of the extremely early universe, what it unveiled wasn't the expected scene of an infant, chaotic, and disorganized cosmic nursery. Instead, it presented a vista brimming with large, fully formed, and surprisingly mature galaxies. Shamir's unsettling conclusion? If the Big Bang Theory, as scientists initially conceptualized it, remains accurate, then the sheer existence of these fully developed galaxies at such an impossibly early stage effectively renders them older than the universe itself, a staggering paradox that seems to defy the very fabric of time and causality. Now, cast your gaze upon this image, if you will. You are beholding a galaxy that is, quite literally, blowing scientists' minds and forcing them to recalibrate their understanding of cosmic history. It has been christened Zuulong, and it represents a recent, monumental discovery by astronomers utilizing the formidable capabilities of the James Webb Space Telescope. What sends shivers of disbelief down the spines of astrophysicists is this. Zuulong is not just any galaxy. It is a fully formed, elegant spiral galaxy. Remarkably, the oldest spiral galaxy in the early universe we have ever discovered. This cosmic marvel existed when the universe itself was a mere infant, only about 1 billion years old. That is an almost inconceivably early epoch in the grand tapestry of cosmic time. For a sense of perspective, our universe today has aged to a venerable 13.8 billion years. Here lies the crux of what is truly freaking scientists out. Galaxies of this sophisticated caliber, especially intricate spiral ones adorned with neat, beautifully well-defined arms, are simply not supposed to exist so early in the cosmic timeline. They are the grand old oaks of the celestial forest, not mere saplings. According to the meticulously constructed edifice of our current cosmological models, these kinds of complex, majestic galaxies should require billions upon billions of years to coalesce and fully form. They are theoretically expected to embark on a painstaking, gradual growth journey, often through tumultuous and messy mergers with countless smaller, irregular galaxies. But Zuulong, in its audacious defiance of expectation, already presents itself as a paragon of maturity. It boasts a distinct, luminous central bulge teeming with ancient, venerable stars, a vibrant, active disk where new stars are passionately igniting and being born, and unmistakably clear, sweeping spiral arms. A striking, almost uncanny resemblance to our very own home galaxy, the Milky Way. In fact, the resemblance is so profound, so startling, that scientists are affectionately, yet perplexedly, referring to Zuulong as the most distant Milky Way twin we have ever had the privilege of observing. Its astonishing size and intricately structured form simply, stubbornly, do not compute under the standard cosmological model, which, until now, has served as the foundational bedrock of everything we thought we knew about how the universe originated, shaped itself, and majestically evolved over eons. It's like finding a perfectly constructed skyscraper built mere moments after the ground was cleared. Muin Xiao, the lead author of the groundbreaking study and a postdoctoral researcher at the prestigious University of Geneva, articulated in a formal statement that what truly sets Zuulong apart, making it a cosmic outlier, is the sheer extent to which it mirrors our Milky Way. A breathtaking similarity observed across its overall shape, its considerable size, and its impressive stellar mass. While Zuulong is, without question, undeniably older than our Milky Way in terms of its appearance in the cosmic timeline, it could, with startling ease, be mistaken for our galaxy's little, precocious sibling. The new, exhaustive research estimates that Zuulong's magnificent, star-forming disk spans an impressive breadth of approximately 60,000 light-years across, a respectable size compared with our own galaxy's expansive 100,000 light-year breadth. Furthermore, it harbors an estimated 100 billion solar masses, a significant accumulation compared with the Milky Way's colossal 1.5 trillion. Yet, despite these quantitative differences, Zuulong stands out, by a considerable margin, as the largest and most well-defined Milky Way look-alike ever spotted at such an incredibly tender and early stage in the universe's convoluted history. And here's where the narrative takes an even wilder, more bewildering turn. It's not merely a solitary, anomalous galaxy like Zuulong that we've chanced upon in the primordial universe. Oh no, we have actually observed several other spiral galaxies, each displaying a surprisingly uncanny resemblance to our own, inexplicably popping up at times far earlier than any theoretical framework suggested they possibly could. The groundbreaking discovery of Zuulong thus joins an ever-growing, unsettling list of remarkably well-formed, Milky Way-like galaxies meticulously identified and cataloged by the James Webb Space Telescope, all existing in the universe's startlingly early infancy. This, without exaggeration, is a monumental deal, and honestly, for the dedicated scientists laboring to reconcile these findings, it's becoming a bit of a cosmic headache. According to our deeply ingrained current understanding, galaxies as intricate and majestic as the Milky Way demand billions of years to slowly coalesce, grow, and majestically evolve into their mature forms. Our very own galaxy, for instance, embarked on a patient, protracted journey of approximately 13 billion years to blossom into the grand spiral we inhabit today. So, how, then, are we witnessing galaxies that appear virtually identical to ours, already fully formed and thriving, a mere 1 billion years, a cosmic blink, after the Big Bang? It simply, emphatically, does not add up. The numbers, the timelines, and the observations are in stark, screaming contradiction. Some scientists are now compelled to pose a truly profound and unsettling question. Why does the early universe, in these astounding observations, seem to so perfectly mirror the sprawling, mature universe we gaze upon around us today? It's as if we are looking through a cosmic window into the past, encountering perfect, bewildering cosmic twins, and no one, absolutely no one, possesses a definitive answer as to how or why they managed to materialize there so impossibly fast. This extraordinary anomaly is forcefully compelling us to fundamentally rethink and potentially entirely rewrite the entire established timeline and mechanisms of galaxy formation. But believe it or not, the surprises do not end there. The James Webb Space Telescope, a relentless cosmic explorer, has just unveiled yet another revelation that is leaving scientists even more utterly puzzled, pushing the boundaries of what they thought was possible. In a brand new, meticulously peer-reviewed research paper, scientists report that they've unequivocally identified galaxies that appear to exist at distances, and thus ages, far beyond what our current models deemed achievable. According to their painstaking analysis, Webb has detected galaxies at redshift values soaring higher than 15, and, in some cases, possibly even reaching an astonishingly high 20. To put this in the simplest, most digestible terms, the higher the redshift value of an observed object, the further back in cosmic time we are actually looking, essentially rewinding the cosmic clock. A redshift of 15 or greater means we are literally peering at these galaxies as they existed when the universe was only about 100 million years old, a mere cosmic blink, an infinitesimal moment, after the cataclysmic Big Bang. Imagine a newborn infant displaying the wisdom and complexity of an elder. That's the scale of the anomaly. In this latest, mind-bending study, the dedicated team of astronomers meticulously selected 10 specific objects from Webb's vast and intricate AstroDeep catalog. These chosen objects exhibit precisely the right colors and unique photometric properties to strongly suggest, with high probability, that they are indeed residing at these extreme redshift values of z equals 15 to 20, unequivocally positioning them among the absolute earliest, most primordial galaxies we have ever had the privilege, or perhaps bewilderment, to observe. Herein lies the truly shocking, paradigm-shattering part. If these fledgling galaxies genuinely are as ancient as their redshift values indicate, then their formation process must have been incredibly, impossibly swift, occurring in mere millions of years, rather than billions, just a cosmic heartbeat after the Big Bang. That time frame is not just early. It's astronomically earlier than our current, painstakingly developed theories ever dared to suggest galaxies should even begin to exist. It's like finding a fully formed city built in a single day. Scientists, as is their rigorous nature, are understandably maintaining a healthy degree of skepticism and caution. They are now urgently calling for detailed spectroscopic tests, the gold standard for cosmological measurements, to definitively confirm the exact distances and, critically, the precise ages of these astonishingly ancient galaxies. But should those critical tests corroborate what Webb's keen eyes have already revealed, then this cascade of discoveries could, without hyperbole, fundamentally shake the very foundations of modern cosmology, triggering a scientific revolution unseen in decades. Collectively, all these groundbreaking, often contradictory discoveries by the James Webb Space Telescope have not just challenged, they have completely and utterly turned our previously well-established understanding of the universe and its majestic, mysterious evolution irrevocably upside down. Until very recently, the prevailing scientific consensus painted a picture of the early cosmos as an incredibly quiet, almost desolate void, a profound darkness stretching for hundreds of millions of years after that pivotal moment we call the Big Bang, utterly devoid of the shimmering light of galaxies. The common belief was that the universe needed far more time to sufficiently cool and for matter to coalesce enough to ignite the first stars, let alone form intricate galactic structures. However, the revolutionary gaze of the James Webb Space Telescope has dramatically flipped this long-held notion on its head. With its unprecedented infrared capabilities, Webb has peered back through cosmic time and astonishingly spotted fully formed galaxies, some even boasting the classic, majestic spiral structures, appearing mere hundreds of millions of years after the universe's birth. This incredible discovery places them squarely in the midst of what we once quaintly referred to as the cosmic dark ages, a period thought to be characterized solely by neutral hydrogen gas, before the first stars had even begun to reionize the universe. How could such complex celestial cities emerge so quickly when the prevailing models suggested the universe was still in its infancy, barely stirring? Furthermore, as if challenging our understanding wasn't enough, Webb's meticulous observations have unveiled another profound enigma. The expansion rate of the early universe appears to be fundamentally at odds with the rate we meticulously measure in the nearby, more mature universe. This glaring discrepancy, which scientists have aptly termed cosmic tension, is no longer a minor anomaly to be brushed aside. It's becoming an increasingly insistent and undeniable problem, gnawing at the very foundations of our standard cosmological model. Consider the ramifications. If the universe isn't expanding at a uniform, consistent rate across all epochs and all regions, it introduces a deeply unsettling and profoundly troubling possibility. What if our entire concept of a singular, fixed age of the universe is fundamentally flawed? Could it be that the age of the universe isn't a universal constant, but rather a variable, potentially shifting and differing depending on where you are looking or when in cosmic history you are measuring? This isn't merely a minor adjustment. This completely upends and challenges the core tenets of our current cosmological models, most notably the lambda-CDM model, which has been remarkably successful for decades. It implies that the very methods and assumptions we've employed to measure the universe's age, to trace its evolution, and to understand its fundamental parameters might be fundamentally flawed at their deepest levels. And if that's the case, then virtually everything we thought we understood about the universe's origins, its trajectory, and its ultimate destiny might need to be rigorously reevaluated, rethought, and perhaps even completely rewritten. These paradigm-shifting findings have inevitably compelled scientists to venture into the realm of truly bold and imaginative new theoretical frameworks. Some eminent thinkers, like the Nobel laureate Roger Penrose, propose a cyclical model, suggesting our universe isn't a standalone event, but rather an aeon that emerged from the death and evaporation of a previous one, perpetually regenerating in an endless cosmic cycle. Others speculate about the existence of a mirror universe that perhaps predated our own Big Bang, possibly running in reverse time or composed of antimatter, offering a symmetrical counterbalance to our known cosmos. There are even those who daringly hypothesize that the universe might not have had a distinct beginning at all, challenging the very notion of a Big Bang as a singular origin point, suggesting instead that it could have simply always existed in some form or another. Adding to this intellectual ferment, there are now even radical ideas positing that the perceived expansion of the universe might, in fact, be an illusion, a trick of cosmic perspective, and that those enigmatic entities we call dark matter and dark energy, which currently account for roughly 95% of the universe's mass energy budget and are crucial to explaining cosmic structure and accelerated expansion, might not even exist as distinct physical phenomena. Such a revelation would dismantle decades of astrophysical research and force an entirely new understanding of gravity and the very fabric of space-time. Thank you for watching.